All right, welcome to this week's Tech Insight webinar series. This week we're talking about Azure Kubernetes services and containers, a very hot topic among the dev domain and people moving to the cloud. We have some great guests this week. My name is Nathan Lesnowski. I'm Concurrency's Chief Technology Officer, and with me are Brian Hayden and John Hubert. Brian is a managing architect from Concurrency. He's an expert in modern apps development. Welcome, Brian.
Thank you.
And then also joining us is John Hubert. He is a senior systems engineer with Concurrency, does a lot of work on Azure Kubernetes services implementations, and he's going to be covering a lot of that detail with us today. Welcome, John.
Nice to be here.
Awesome. Well, let's get to it. So what we're going to talk about today is why containers, how and when to use them, especially versus native services and serverless or maybe your legacy infrastructure. And then also what it looks like to move applications into containers and some of the learnings that we found in the process of doing so. We're also going to have a webinar coming up on October 8th, where we talk about application refactoring, why you might refactor an application in a cloud migration, what those best practices look like in re-architecting applications, especially where those quick wins are, and then how to avoid common pitfalls and unnecessary costs in that process. So let's get right to it in talking about Kubernetes. So first, why containers and why Kubernetes? What are containers? So you may have heard a lot about virtual machines. You may have heard about serverless. Both those concepts can feel a little intuitive or things that we've been working with for a while. But sometimes containers can feel a little bit like a mystery for people. So we want to make sure we break that down for a second. So container is just another level of abstraction. It's a standard unit of software that packages code with its dependencies and runs on top of a computing environment. It includes everything necessary to run the code. So if you were to contrast that with a virtual machine doesn't include all the things necessary to run the code. It just includes the system tools and the basic platform of the operating system. This includes all aspects of the application: code, runtime, system tools, libraries, settings, everything you need. And then multiple containers are run on a single operating system kernel, meaning that there's less duplication happening in the compute cycle. It's allowing for one platform to run more things and more standardization to occur in how we distribute them. One of the things that's happening right now is an incredible momentum behind Kubernetes as a platform to execute on the container workloads. So right now, really, if you're building a custom application, you're either thinking about running it on Kubernetes or you're thinking about running it on serverless. And these platforms are growing at an exponential rate. 75% of global organizations will be running containerized applications by 2022. Cloud native development is incredibly scaling, and 65% of developers are using orchestration to manage those services as they look at it in 2022. So we're seeing a lot of momentum in this direction, which is potentially the reason why you're on this conversation today. So we're going to break that down. If you were to compare that against a virtual machine for just a moment, and this is what we were talking a little bit about earlier, you'll see that in a virtual machine infrastructure, you have your hypervisor and your host operating system, but then each of the applications are running their own instance and duplication of the guest OS. That duplication eats up performance. It eats up, and it also eats up the optimization of the environment, but then also leaves holes within the available capacity that exists within the infrastructure. And then from the concept of deployment, it eats up a lot of the duplication of having to not only deploy the operating system and infrastructure, but then having to have a separate deployment that pairs with the deployment of the app. When we look at a container, it brings all those concepts together inside of leveraging a shared container runtime, a shared operating system, a shared infrastructure inside of the package. So it brings a lot of optimization to the performance environment, but also brings portability, scalability, and an easier deployment model to the deployment of the application into a production or a dev environment. So the idea that works on my machine is a real advantage of running containers. So that whole idea of why containers, why even do this? It eases the deployment channel. It eases the opportunity for the environments to look the same between where you built it, where you tested it, where you deployed it. It increases the velocity of deployment. it increases portability between environments, and it has an aspect of run anywhere in the sense that all I need to do is ensure that I have the necessary performance for me to be able to sustain the needs of the container versus spending as much time on the underlying aspects of the application. So let's dive into asking our experts. So Brian, can you tell us a little bit about what are the benefits of developing on containers? Why would I use this as a development model?
So the traditional benefit of developing on containers is portability across different cloud platforms or just different platforms. You brought up the concept that works on my machine, and that each of the container environments are as they're deployed, they're identical. But let's talk a little bit about serverless architecture and different type of architectural patterns and why containers can make sense for your organization or not. We start traditionally, development over the last, 15, 20 years has been this monolithic approach where you have, your typical 3 or N-tier type of development system where your user application talks to a layer business, which talks to data, and everything's kind of built together. If you're doing it right, you're using solid principles, so at least you're following good development practices and architectural practices, but there's always tight coupling across these domains. So over the last few years, we've seen a transition to microservice architecture, which is the more modern approach. You're separating your services into single areas of concerns, and it simplifies these services so that they only perform a useful function to the application. There's no tight coupling. There's some loose coupling. You can see in my diagram about the microservice architecture that you could have a microservice that manages 2 other microservices. So there could be some loose coupling, but there's no dependencies. And the other part about microservices that are nice is that with this loose coupling or no coupling, each of these microservices are highly testable, and that creates much more efficient code, much less problems. So now let's talk about containers. That sort of expands it really expands like this microservice approach, but it reduces the dependencies because, as you alluded to, you're not working with OS dependencies anymore. You're fairly agnostic. And as Microsoft moved to .NET Core, a natural transition to containers is something that you may want to consider. It has less dependencies on cloud architecture, and it is the most independent. So what does this mean for a developer, and why would you want to do this? Why would you want to do containers? So this work from my machine is a great concept. If you think about a traditional architecture as you're doing a development platform, you have all of your different microservices sitting up in a cloud. And if your developer is working on a specific service, he or she might want to work on maybe the user interface service, or maybe something else. So what you would wind up doing is you wind up connecting all these different services, and it's a lot of setup. You have to spin up this microservice. You got to have your web APIs working. With the containerized development, all you get to do is run the container locally. And since it is an independent container, you can develop with just that architecture. There's no external dependencies that you have to connect to, no necessarily a database server that you have to connect to, or there's none of that. So that's a main benefit for the developers to want to consider this, is that you can be highly efficient with it.
Awesome, thanks, Brian.
Yep. Here this is kind of what I was talking about with the development experience. So you can look at the different containers that I have up in the cloud, and the storefront container as an example. I'm going to do some work on that. So I'm no longer using the storefront container in the cloud. I've now brought that down from a development standpoint to my local workstation running in Docker, and I can do my development locally.
So what are the challenges? It sounds like there's a lot of advancements and benefits of doing this. What are the challenges of developing on containers, Brian?
So there's a couple of areas of learning curve. The two most important are that you're probably going to want to consider .NET Core, which if you aren't already doing that, there's a learning curve of getting yourself from the .NET standard framework or traditional frameworks up to the .NET Core. So there's some of that. In addition to that, there's a learning curve with just working with Docker containers and how do you actually work within the container environment. So the biggest challenge, I think, the biggest challenge for most organizations is this adoption aspect of it, and just getting people to be skilled and have skilled workforce around it, and also a comfort level. But more importantly, there's other technological concerns around this. The one that I hear the most is security. So I think John's going to talk a little bit more in depth about security around this, but as you build out your containers, you have more control over that environment, and you have to have people that are going to pay attention to that. The vulnerabilities within a container not only affect just your container or container to container communication, but most of these containers run on like a Linux core OS where it has root level access, and a compromise from the container itself could compromise the host OS. Additionally, you know, you kind of have to determine when it's right, when it's appropriate for you to use containers or not. There's still a place for monolithic development practices. Think of developing a small application for your HR department where there's 5 or 6 users and you don't really have to worry about scale, and it's only performing a couple of simple functions. You know, to deploy that into containers is going to increase the complexity of your application development, and you're probably not going to see any ROI on that. So make sure that you consider, you know, the use case of whether it's appropriate or not. And then testing, right? So a big part of developing containers are making sure that all these different components are going to work, and they're going to work at scale. You know, we talked about some of the benefits, and nice part about containers is that, you know, these containers can just magically appear and scale. So being able to test these and having good rigid test practices around your container development is imperative to having a successful development environment.
Awesome, thanks, Brian. Let's move over to John for a second. John, what does a typical container infrastructure look like? You know, I'm hearing Docker, I'm hearing Kubernetes, like kind of break that down for us a little bit.
Yeah, typically we use several components in Azure to build that out. We start with source control and pipelines. That's really the interface that you're going to want to use to interact with your containers. You can build these manually in dev environments or on your laptop, but to really do this at scale and know that you're having a repeatable process, you really want to use source control and have those managed automatically. The next major component is a container registry, because as you develop these, they're going to have some place to sit. So we use the Azure Container Registry, standard registry, but it's nice that it integrates with Azure AD's role-based access control. And so then the other component that goes along with that is Azure Active Directory for several parts of the management of the entire infrastructure, back to other resources that are used, pulling images and managing the cluster. So source control, container registry, and Azure Active Directory are the primary components that we'll see there. Typically, in Azure AKS itself, we've been typically running Linux workloads. We've not seen a lot of uptake on Windows node pools in Azure AKS, but they are supported. So we're looking usually at Linux, and then just some of the other the features there. Storage is usually defined on an application by application basis, so we haven't seen necessarily a single common pattern for the databases that are used, but we have not had a lot of stateful data stored in Kubernetes itself. We're looking at getting the stateful data out to other Azure services like Azure SQL Database or Blob Storage. So those are the main components that you're going to see is the developer process through Git and source control, container registry, AKS with Linux node pools, and then Azure Active Directory as kind of our common pattern that we're going to see as the main components.
Awesome. So how is container orchestration different from the containers themselves?
You could think of a container more as your application or your deployable, executable piece of code. The orchestrator itself acts more like the operating system that would execute that. So you're going to pull in instances of the container and execute them, but you want to worry about the check the life cycle of them, make sure that they're running on separate nodes. Manage security, manage secrets that are being passed into those containers. So there's all that other infrastructure that comes with your orchestrator, and managing the credentials to pull them down even onto those containers, the containers onto the nodes that they're going to run on. So where you have the container is a small bundle of code, the orchestrator is what makes sure that everything else runs smoothly.
Mm-hmm. Can you talk a little bit about like what exactly Azure Kubernetes Services does to a container? You know, I'm deploying it from the registry. I've got my code in the container. It's being deployed. What is Kubernetes Services actually doing?
Kubernetes Services is going to look at a manifest to see what you want to be executing and what permissions that you want that container to have. It's going to tell the Docker services on the individual nodes, which are VMs that are Azure VMs that are being managed by Kubernetes. It's going to tell them to pull the container down from the container registry, and it's going to pass secrets in so that it can go log in and pull those down securely. It's going to look at your manifest and see how you want it to run, what resources it should have for memory or for processor, any other dependencies, like making sure that your multiple instances of a single microservice will be running on separate physical nodes, so that you don't have one node go down and take down your entire microservice. So it'll worry about distributing those. It'll make sure that the load balancers that are deployed, as individual instances of a service come up, the load balancer starts using all of them or starts pulling them down, and then runs health checks across each one of them. So those are the main features that you're looking at with Kubernetes. It's also doing things like managing other secrets or giving you a single control plane to log in and pass those manifests in so that it knows how to keep running. So the entire API itself is what is Kubernetes on that managed plane from Microsoft.
You know, one thing I feel like people have a lack of good understanding of when you're just getting into containers is what is Docker and what is Kubernetes, and they almost think like they compete, but they really don't. They're kind of symbiotic, and maybe Docker Swarm would be the true competitor against Kubernetes in a sense, but Kubernetes won. You want to just talk about that real quick?
There are multiple orchestrators out there for containers. Docker Swarm was another one from Docker itself. You can use other orchestrators to do this or build something manually. Kubernetes came is from the open source community, originating at Google with some of the work that they had done, and has just taken over the space. It has primitives for things, managing things like your load balancers and security in that package. So it's in some ways more feature complete, or at least more, well, gives us more points to integrate out into other things that we're going to need than where we were with things like Docker Swarm. So this is just the way the community went. You could have used other things. There are tools from HashiCorp. There were other tools from Microsoft that can do similar things, but this is the common language, the common APIs that everyone was moving towards. So Microsoft gives us a fully managed platform, but then in Azure, it gives us access to things that are unique to Azure in there for managing storage, for managing load balancing, for secret storage, integrating with role-based access control or networking components. It's leveraging the base infrastructure in Microsoft Azure for those components instead of having to build out your own with virtual network overlays or worrying about secret storage. So we come around, we use top level resources in Azure, but then we manage it here with Kubernetes. Docker itself is a runtime that they're running on the hosts, but that is your application itself. It's not all the other components that you'd be using.
Awesome, thanks, John. So Let's talk a little bit about, John and Brian, what are the learnings from building a container infrastructure and running applications in it? Like what are the things that, with maybe putting security to the side for a second, because we're going to talk about that in a minute. What are the major learnings that you've run into and things that you would have done differently after you've done this a few times?
So I'll go ahead and go first, John. One of the things that I've seen fail projects, or at least cause cost overruns, is not being mindful about your dependencies within your containers. So we've had projects that have gone off the rails where some of the development may have been too dependent on a cloud provider's offerings, and once you do that, the portability aspect of the containers disappears. So the idea that you'll be able to take a container that is in GCP and have that same container in Azure, if you're using cloud dependent providers, is going to break that mold. The other thing is that containers are stateless by nature, and that's what you're supposed to be. You have to start thinking about containers as being stateless, and too often there are stateful paradigms built into the containers that are difficult to overcome. So going back to the application architecture, it has to be well thought out and understand what a container is good for and what it's not. John?
Yeah, especially when you're migrating older software, having good tests in your pipelines for that software so that you know that you're getting similar behavior as you migrate is critical. Or at least being able to come up with a way to test and make sure that your application in containers matches the performance and behavior that you had when you were running in a more traditional environment. So remembering that there are definitely container patterns that you want to follow. We've done a few of these where it was migrations that we're starting from more of a traditional deployment, or development was going on locally, not without using containers on the developer workstation, but then trying to just build the container just for the deployment, and that was not smooth. You should build out a full container deployment environment and really leverage the containers for the entire software development workflow from the beginning. But also testing and making sure that your deployments and all your code really is getting into source control. There are a lot of clients that we've worked with have done the deployment from a developer workstation and had a lot of hand-built YAML deployments, or we're using the portal to do a lot of the deployments, and that really does not lend itself to the repeatability and testing that you need to be doing. And then also the proper instrumentation is really important. So we've been doing a lot with App Insights on these, because once you start getting these services built out and you're running in multiple containers, finding your performance pain points is difficult without some good instrumentation there. So getting into something like App Insights with your containers, we think, is really important.
Awesome, thank you. All right, now building on that, John, could you talk a little bit about security considerations with the containers? I know that's an important topic, and it's something that people can have some missteps in.
Yeah, there are several layers of security to think about. Like you would with normal infrastructure, you have your standard management and control planes in your infrastructure. So Kubernetes itself, making sure that that's secure and the API is secure. Microsoft lets us lock that down in different ways. By default, your access, could be public on the internet, that API, but you can bring that inside. You can put firewall rules in front of it. You can secure that with Azure Active Directory. So knowing who's managing your machine, or what security principles from your pipelines are interacting with that. So that's the first layer. Second, you have your containers themselves and your software. When you're building that container, it's not just your code in there, but you also have dependencies, operating system dependencies, other applications that might come with it, a shell that you might have in there. Those all need to be patched as well. So there's tooling in Azure Container Registry, the things that you can do in your pipelines to scan your containers, scan your running containers, make sure that they're running right, and that the other components aren't running with security vulnerabilities, and make sure that you're rebuilding your containers with the newest code, because when you run normal operating system updates, you're not going to be getting patches for those containers. That's more on you in rebuilding your containers and getting those deployed. In the containers themselves, you typically don't want to be running them as root, and Kubernetes gives you some options right in the manifest to make sure that you aren't running with privileges that you don't need, so limiting your access to the kernel. But these are all running on the same kernel. So where you were running in separate VMs and you had isolation in memory isolation with your VMs and a hypervisor that was really locking those down, now you are running them all on the same kernel. So you want to make sure that your security settings around the containers are as least privileged as possible. Docker provides some of that at an operating system level, and then Kubernetes helps us wrap the policies around that. Also, each of these are identified basically by an IP address. Everything talks over IP, and there are controls in Kubernetes to limit access between containers, or by defining either around the namespaces or the containers themselves to limit where the traffic can go. And then around your VNets itself, you still have your normal controls that you have for network policies there as well, so that you can use access control to prevent traffic from moving where you don't want that as well. So your normal settings on your VNets are going to be applicable there as well. You do also have to worry about patching your node pools. The hosts that on the management plane are going to be patched in AKS automatically, but your node pools, Microsoft really doesn't know whether your applications are built to be recycled automatically. So there is some requirement for you to make sure that you're letting AKS patch and reboot the underlying hosts in your Kubernetes cluster.
Wow, awesome information, John. Thank you so much for digging into that. I think we could probably talk all day about security, but I appreciate the kind of 5-minute overview there.
Yeah, and Microsoft in their documentation for AKS does lay out a lot of best practices around security. So you just want to make sure that you've read up on that before you dive in on production.
Awesome. Well, big thanks to our guests, Brian and John. Awesome information today on diving into Kubernetes, talking about why you might choose it, what the benefits are, some understanding of the architecture and security concerns and questions. So thank you so much for your work today and your conversation about that. What we would love to do as a next step is we would love to meet one-on-one with you to talk about how Azure Kubernetes is part of your application development lifecycle and how you might be considering it as part of either new builds or refactoring applications within your environment. We also have a webinar next week that's very similar in sort of related topic, which is about application refactoring for cloud migration. This is a key area where organizations are considering Kubernetes. It's also a key area where there's other technologies that you might be bringing to bear as well. So don't miss our webinar next week, specifically on application refactoring for cloud migration, particularly a huge part of when organizations are considering a large lift to the cloud, but aren't wanting to lift and shift quite in an IaaS format. They're wanting to move out of IaaS into other kinds of models. So definitely visit us next week, or excuse me, on October 8th as we do that webinar. And then of course, visit concurrency.com for blogs, videos of previous webcasts, as well as other resources. Thank you for joining us today and have a wonderful rest of your Thursday.